it's going to take you to like yeah, where you've saved your data, and then you look for it. And then the shortcut is just clicking on that kafao uh, symbol there. You click on open, and then it's going to do the same thing. All right, so that's the purpose of this kama logo there. And then this next one is just for saving. For instance, you've worked with your Stata, and then before exiting you want to save, you just click there, then you're going to save. Okay, so the second one, that one is for saving. And then this kama one here is for printing. All right, let's say you want to print something, you want to print your output, you want to print your commands, you just go there and it's going to print. Okay. And then for the log one, we use the log function if you want to, like, there is a way in which Stata is going to store your data. Okay, let's say you want to store your command in Stata language. You just go to log, you click on log, and then the moment you click on log, you go to the folder where you want to save, to be saving your output. And then after doing that, everything that you'll be doing will be saved in that particular folder.
Okay.
And then with this one, it's one of those useless options that we have instead. And then for this one, it's just for graphs. As you can see, there's something like a bar graph there. This one is just for graph. Okay, but the most important ones starts from, let me say, it's just this common one here, this one, and this one, maybe to some extent even the variables manager. So let's start with what we call the do file. The do file is more like when you click on the do file, all the commands that you'll be, let me just say, everything that you'll be doing in Stata will be recorded. So for instance, let's say you are entering commands and then you don't want to enter the same commands next time. You just use your do file, and then everything will be stored in your do file. Meaning that next time you open Stata, you open your do file, you're just going to be clicking on those commands, and then the output will be coming. So instead of you going back to the drawing board and do the same things that you were doing last time, you can just use your do file. Okay, you can just use your do file, and then you just click on those commands, and then Stata will be giving you the output. So we usually use the do file, like in most cases we use the do files because we don't want a situation where, let's say, you've forgotten how to do a command, and then you start going back to books and start reading and start studying and all that. You just go to your do file and click, and then the output will start coming.
Okay.
And now the next one, this one here, is what we call the data editor. Okay, so with the data editor, it's more like self-explanatory in the sense that it's just there to help you edit your data. Okay, so when we are copying data from Excel onto Stata, we use the data editor so that we can arrange the data in a particular format that we want. So in short, the data editor is just there to help us edit our data set. Okay. And then with so there are two. There's the data editor edit, and then there's the data editor browse. With the data editor browse, you are just going to browse through your data without making any edits. It doesn't give you the privilege to edit your data. You're just going to check through your data and all those things. It's just there to help you browse through your data. Okay. And then with the variables manager, we use the variables manager if you want to format your variables, you want to change the names. Let's say you want to change from let's say you want to convert your data into string variables, or maybe you want to convert them from string variables into other types and all those things. That's why I use the variables manager. So the more you use this data, the more you're going to know how to use all these tabs that we talked about. Okay, so with this data, the key is practice. You just need to practice. So for instance, whatever we're going to do today on your own, you try to run through. That's how we know Stata. Otherwise, it's not a complicated software. Okay. All right. So we'll start with how to load data. I hope you have your PC there and you also have your Stata installed.
Yes, I have.
Okay, so should be doing what I'm doing so that we are on the same page. So first question, do you have the data set for assignments on your PC?
No, it's in my phone.
Okay, well then you just follow through what I'm doing, then later on you try to do that.
Okay.
So first thing first, for me, I've just gotten the same data set that you've sent. I've just put it on my PC and it's saved on my desktop. Did I even save it? So first thing first, you download that data, then you save it. Let me save it. I'll put it on my desktop. Now just name it assignment dataset. So oh, it's open somewhere. Anyway, so the first thing is you're supposed to make sure that your dataset is saved somewhere, and then you open it. So the way it has come, it's in Excel format. Okay. Your dataset is in Excel format. So this is how your dataset is. It's about quite a lot, about 530 or so variables, 530 data points, sorry, not variables. So what you do is you just copy everything, okay, like that, then Control C. You've copied everything, right?
Yes.
Now you open your Stata. So let's use 16. You open your Stata and then you go to the data editor. Okay, there on the data editor. You click there. When you click, then it's going to give you a blank spreadsheet. Okay, it's going to give you this blank spreadsheet. It's going to give you this blank spreadsheet. Then you paste your data here. Okay, so how do you paste? You go to actual paste, not paste special. You go to paste, you click, then this comma window is going to pop up. Okay, so it's asking you, do you want to treat the first row as variable names or as data? So what we want is, when you look at your data in Excel, the first row has got variable names. You see that, Ka?
Yes.
Yeah. So you want to maintain your data the way it is here, so that the first row is just for variable names and then data is starting from the second row. So you do the same in Stata. So you click on variable names. When you click there, our data has been pasted onto Stata. That's okay, right? Is that okay?
Yes.
Okay, so now we have our data here in Stata. So as you can see, it shows that the data has been pasted and Stata has recognized this as our data set. So how do we know that? We check from the variables here. All the variables have been marked and they are showing. Okay, so this is the same data that is in our Excel. It's the same data that is in our Excel. And now we've we've opened the same data set using Stata. So what we've done so far is just copying the data from Excel and putting it onto Stata. There's no analysis that we've done whatsoever. Okay. Yes. So that's the first thing that you're supposed to know: how to copy data from Excel onto Stata. So that's the first thing. The second thing is that we should now look at how you save this data set so that you save it in Stata format, or what we call DTA. Okay, so you're supposed to save your data now in DTA so that it can be converted from the Excel data to Stata data, and the only data type that opens in Excel is what we call DTA. So how do you do that? You go to File. Okay, that is after pasting your data here. You go to File, click there, and then you go to Save As. Or in short, you can just Control Shift S from here. Okay, you can just Control Shift S, then it's going to show you how you're supposed to save. Okay, so you open File, you go to Save As. Okay, or if you want, you can just go straight to Save, but I prefer Save As, because when you use this option, you have an option to, like, you have power to save your data in whatsoever folder that you want. That's okay, right?
Yes.
So you click on Save As. Okay, after that it's going to give you the more like that privilege for you to save your data in whichever folder that you want. So for me, let's say I want to save this data on my desktop. So this is my desktop. So I'll then, if I want, I can then decide. Let's say I want to put it in, let's say IDE folder. I'll just click there and then put the name there. So let me call this assignment data set. Okay, like that. And then after putting the name assignment data, then you click on you include the full stop. Okay, then you put DTA, meaning that as you can see here, the moment I've put DTA, it has shown here that this is Stata data. You see that, right?
Yes.
Then you click on save. So I've saved in desktop IDE, then I click on save like that. So now if we try to open that folder, we should be able to find our data there. So it was in, what was the folder again? Oh, I think it was IDE, then research. No, it should be somewhere here. Here. So this is the data. You see that assignment dataset.dta.
Yes.
You see that, right? So
Yeah.
the only thing that we've done in this case is just converting our data from Excel to assist to Stata. So now we have our Stata data set. So in short, this is what you're supposed to do for you to start working on your assignment, because the way it is, the way your data is just in Excel, in Excel format. So there's basically no proper analysis that you can do unless you use data. And for you to use this data in Stata, this is what you're supposed to do. So you get your data, you paste it onto Stata, then you save it as a DTA data set, because that is the only data that can be used in Stata, or the only data that Stata recognizes. That's okay, right?
Okay. Yes.
Okay. So with that, the next thing that we can do is so now that we've saved our data here, we can try to close our Stata. Okay, so let's close our Stata and then load this data. In short, now that we've converted our data from Excel data set to Stata data set, let's try to do the next thing, which is how we load, or how we load data into Stata. Of course, not from Excel, but the data that we've saved. How do we load it onto Stata so that we can use it? Okay, so to show that, I'll just clear this data which I've loaded. Okay, I've cleared that data. Now the next thing is to load. How do we load? So there are two methods that you can use. The first method is using the command, but I don't want to be too technical now, because this is just when we are starting. Okay, but obviously, let's say in the next session we should now be able to use the command to load data. But for now, I'll show you the manual way. That's okay, right?
Yes.
So how do we do that? We first have to know the actual location of our data. Where have we saved our data? So we've saved our data in like desktop IDE. So our data is in the IDE folder. So what you do is you go on that file. Okay, so you click on file, then you go on open. Okay, then now we know that we've saved our data on the desktop, which folder, IDE, and then this is our data now. That's our data set. So you just double click. You double click, you can see that here it has shown that we've loaded our data. Okay. The other thing that you can see is that we have this directory here showing that we have used this data, okay, which is located on the desktop folder ID, and the name of the data is assignment dataset.dta. Okay, but if you've done whatever you've done and then you see that the output there is in red, just know that you've done something wrong.
Okay.
So anything in red in Stata shows that Stata has not recognized that as a proper command. Okay, so Stata has not recognized that as a proper command. In short, there's more like nothing that you've done. So anything in red is an indication that you have made a mistake in Stata. That's okay, right?
Yes.
So that is the first thing. So we've looked at how to convert the data from Excel to Stata, how we save it, and now how we load the data onto Stata. Okay. The next thing is, of course, today we're just doing the basics. The next thing that we're supposed to know is how to use, let's say, maybe I'll just show you 3 or 4 commands, the prominent ones, and then if at all we manage to use the other commands in the next session, well and good. So the first command that you should know is what we call the browse command. Is what we call the browse command. So basically, with the browse command, you just want to browse through your data. Okay, you just want to browse through your data. You want to, for instance, look at the distribution of your data, how is your data arranged, and those things. So how do you do that? The first rule with this data is, one, you've said that anything in red indicates that you've done something wrong. The second one is that in Stata we don't use caps. All commands should be in small letters. Okay, so all commands should be in small letters. We don't use caps. Okay, so for instance, let me show you this. Let's say I use caps. Okay, even the same browse command, I use caps, and so you see that it has come with or in red.
Yes.
See that, right? So the command browse is unrecognized. Why? It's because this is in capital letters. But I do the same command, okay, but now with the small letters. You can see that it's going to work out. You see that, right? So the first rule is that you don't use capital letters instead. That's okay, right?
Yes.
So even on your own, when you're alone, if you try to use caps, believe it or not, nothing is going to work out. So we have used the browse command, and basically we are just trying to look at the distribution of our data. How is our data? Is everything okay? You're just browsing through. You see that, right?
Yes.
So we're just browsing through just to see how our data is. Alright. Now, for instance, if you want to, because with a browse, you are just browsing. Okay, you are just browsing. But let's say you want to edit your data. Just a second, I'm coming. Hmm? If you can what? Tables. You have to have tables. You have to add tables. Though it did come first. Okay. Why included this was to my blue stars and all that. That one came out clear. Alright, I'm back.
Okay.
Yeah. So yeah, I was saying that with the browse command, you are just browsing. But what if you want to make some changes to your data? You want to, let's say, edit some variables. You want to edit some numbers. What do you do? So in that case, you go to editor. You click there, okay, for editing. So you go to data editor, edit, not for data editor, browse, because with the browse you cannot edit, but if you want to edit, you use that one there. So you just click yes here. So this one now is giving you a chance to make some changes to your data. Okay, let's say that you don't want, let's say, these numbers here to be twos, like let's say the first 4 or 5 entries. You don't want these to be twos, but let's say threes. So you can come there and make those changes. You see that, right?
Okay.
So you can make those changes. So every time make an end to just click yes, which means you are now able to make those changes. So that's the goodness with the data editor, because you can make changes to your data. Okay, but with browse, you are just browsing. There is nothing that you can do. Okay, so don't make that mistake where, for instance, you want to edit and then you go to browse and then you are saying that no, Stata is failing. Stata is not failing, you are the one who is just failing. So you instead go to edit, data editor, edit, because that is the only option that you have for you to make some changes to your data set. Yeah. Okay, that's okay, right?
Yes.
Okay, so that's one thing. The second thing is there's another command which we call the, so we have the browse command. I don't want us to rush into regression. So there's the browse command, and then there's also what we call the tab command. Okay, so with the tab command, you are just tabulating. Okay, we're just tabulating so that you can understand the distribution of your data. But the funny thing with this command is that it just gives you a summary of your data. Okay, the simple summary. So for instance, we want to understand how age is distributed in our data set. So just go to tab or tabulate if you want, you finish it. but in most cases just use a shortcut tab, and then you put the particular variable that you want to analyze. And please be careful when putting this particular variable. You put like the wording should be the way it is here under the variable names here. Okay,
Yes.
if it's in small letters, use small letters. If the name of this particular variable is in caps, you put caps. But listen, remember what I've said. I've said that the command should not in caps, and in this case the command is the tab, the tab. That's the command. Okay, so
Okay.
the command should be in small letters. Then the name of the variables must be, it must be the way it is showing under the variable names here. Okay, so let's say you want to tabulate age. So age is in small letters, so you just say tab age and then you click enter. So this is the output. This is an output for age. It's showing that uh, basically our the age of our respondents was ranging from 29 to 37 years. Okay, so that's the first thing that we're able to see from this data. We are seeing that the age distribution is ranging from 29 to 37, which means that the youngest person who was interviewed was 27 years old, and the oldest was 37 years old. So that's the first thing we're able to tell. The second thing that we're able to tell is that there were 17 respondents aged 27. Oh, sorry, 29. There were 17 respondents aged 29. In short, with a tab command, it's giving you a summary of your data set. So it's, in this case, it's specific to that particular variable that you are trying to analyze. Okay, so we are able to tell that 17 of our respondents were aged 29, and that was representing 3.2%. So the guys who are 17 years only represents 3.2% of the total number of the respondents. So that is how you make your conclusions. So this is more like statistics, basically. All right, this is more like statistics. So the first conclusion is that we look at the age distribution 29 to 37, and then if the question was asking us to say, based on the data, how many respondents were aged 29, we can just go to tab, we tabulate age and check, and then from there we can get the answer that only 17 respondents were aged 29. Okay, so that's the first thing. So is that understood?
Yes, I've understood.
How we interpret the search results. It's okay, right?
Okay, on the interpretation, maybe just repeat once more on the interpretation.
Okay, so with the interpretation, so first of all, we have the frequency. Okay, we also have the percentages, and then we also have the cumulative frequency. So what we are seeing is that, oh, actually, this is cumulative percentage. So what we are seeing is that, for instance, with the 29 here, this 29, so we have ages ranging from 29 to 37. Okay, we have ages ranging from 29 to 37, 1. And then the second thing is that, for instance, if we're looking at the total number of respondents that were 29 years old at the time, or during the time when we are carrying out our survey, okay, we can say that only 17 of those respondents were aged 29, and that is representing 3.2%. Okay, so in short, 3.2% of our respondents were aged 29, and that means that there were just 17 of them. So these 17 is showing that or the 17 is representing 3.2% of our total number of respondents, and these guys were aged 29. So in short, you just make connections. Just make connections. That's fine, right?
Yes. How about the last column? What does it represent?
Oh, for the cumulative.
Oh, cumulative, yes.
Yeah, so cumulatively. So you see that you have the 3.20 here, which is that one there. Okay, and then the second one is 14.69 cumulative, which means that you're adding. So I'm going to say 3.20 plus the 14.69 is going to give you the 17.89. So yeah, like cumulative. So which means
Oh
that you
yeah,
keep
I
on
remember
adding.
we used to do this last year.
Okay, so that's this. That's the other thing. And then the next thing is, so you can do this for all the variables. You can do this for all the variables. You're just trying to understand the distribution, the frequencies, the percentages, and all those things. You can just use the tab command. Then you're going to have your what's this? Your analysis. So don't forget that all commands should be in small letters.
Yes.
So let's say we just try to prove that using this same tab command, but now we put it in caps, the same variable age. Okay, we see. So we say that Stata cannot give us the output because the command is in caps. So all commands must be in small letters. Okay, so I'm sure that one is well understood.
Yes.
Okay. The second command is what we call the summary command. So with a summary command, just like the tab, you are giving out the summary, or you are trying to understand the summary of your data. Only that with a summary command, it's now going to give you the mean, the standard deviation, which one was the minimum and which one was the maximum. It also gives you the total number of observations. Okay. So the summary of, let's say, let's do the same one with age. So let's try to summarize age. So with age, we are seeing that we interviewed a total number of 531, which means we have got 531 observations, and the average age is 32. Okay, so the average age of our respondents is 32, and then the standard deviation is just 2.2 somewhere there. And just as it was reported when we did the tab, we said that the lowest was 29 and the oldest was 37. The same information can also be realized from the summary command. We are seeing that the minimum, which is the lowest, is 29, and the maximum, which is the highest, is 37. Meaning that our age distribution is ranging from 29 to 37 years. Okay. So we've looked at the summary command. We've also looked at the tab command. Okay. Is this okay so far?
Yes, it is.
No. Okay. Then the next thing is, first of all, I believe you guys have done regression in class.
Yes, we have.
Oh, okay. And I believe that you understand regression by now.
Yes. Yeah, partly.
Yeah, because our analysis, especially in Stata, is based on regression. So if we don't understand regression, then everything will seem to be new. Because now I want to introduce the big fish, which is regression. Okay, so I think we by now you know what we mean when we say a dependent variable. You know what we mean when we say an independent variable. Yeah, you know what we
Yes.
mean when we say a co-integrating variable. You know what we mean when we say an intermediating variable. Those things, because those are like, yeah, the things that we'll be dealing with in Stata. Okay, so coming to your assignment. Your assignment is, there's nothing there anyways. I looked at it and I
Okay.
was just laughing. I was like, why? You guys, you're being spoon fed now. Things
That's
are,
the way it is when you don't see something for the first time.
yeah, anyways, you get there. Get
Okay.
there. Yeah, anyway, yeah, so cool. So now let's try to look at regression. I just want to show you how we do regression in Stata. And I'm sure by now you also know that there is single variable regression, and then there's also multiple variable regression. So with single variable regression, we use it when we are just trying to analyze the impact of one variable on the other. That is with single variable regression. But with bivariate or multiple variable regression, we look at the impact of a number of variables on one thing. Yeah. So, for instance, let's say we are trying to understand the impact of the number of years someone spends in school, which is schooling, on, let's say, his earnings, his income earnings. So in short, you want to look at the relationship between the number of years someone spends in school versus the amount of income that they'll be earning. Or is it true that the more years you spend in school, the then the more income you will have? We want to use Stata to analyze that statement. How do we do it? So in that case, we should be able firstly to identify the dependent variable. We should also be able to identify the independent variable. Okay, so when we are saying the impact of schooling on earnings, it means that earnings is our dependent variable, because earnings, or the amount of income you're earning, depends on the the level of education, the number of years you've spent in school. In short, our regression ultimately is going to look like this. So yi should equal beta naught, let's say, plus beta 1 x1, okay, plus let's say beta 2 x2 plus the error term, called ei. So in short, this is what we call, this one is bivariate because we have got two variables. Okay, it's bivariate because we have two variables. If we are to include a third variable, let's call that beta 3 x3 plus the error term, then it ceases from being a bivariate to multivariate. Okay, so if there is only one explanatory variable, we call it a monovariate, or a single variable regression. If I've got two explanatory variables, we call it the bivariate, because you have got two variables that are trying to explain something. And then if you have more than two, then you have what you call a multivariate regression equation. So we start with a monovariate. Okay, we should look like this. So beta yi is equal to beta naught plus beta 1 plus the error term. Okay, something like that. And I'm sure by now you know what the error term is, because anyway, we are not here to discuss regression, we're here to discuss Stata. So let's look at that. So we are saying that we are going to regress. Okay, we are going to regress, or we are trying to come up with a regression of, okay, so we're going to regress. So with regress, you can write it the way it is in full regress, or you can just say reg. It's the same thing. So these are commands in Stata. You know, you can, so with regression, you can just use reg, or if you want, you can use the whole thing regress. Okay, so we are regressing. So earnings in this case is our dependent variable. So you start with a dependent variable when entering. So you enter the dependent variable the way it is. So in the variable names, it's coming as earnings and everything is in small letters. So you are supposed to just copy it the way it is there and put it there. Okay, so we are regressing earnings on the number of years someone spends in school. Okay, so when you enter that, you have this output here. You have this output here, and I'm sure you've also looked at r squared, adjusted r squared, the f, the p, the t, those things, right?
Yes.
Okay, then I don't expect issues. Yeah, don't expect problems since you've looked at those already. Okay, so we've regressed earnings against schooling, or in short, we're trying to understand the impact of schooling, the number of years someone spends in school, on earnings. How does your schooling affect your earnings? So, first of all, for instance, when you are calculating the r squared, we say r squared is the estimated sum of squares out of the total sum of squares. So now, how do we do that in Stata? Okay, so how do we do that in Stata? Let's start from that. So first of all, we also know that the r squared just shows us the percentage of the variations that can be explained in the model. Yeah, so it just shows the percentage of the variations that can be explained by our model. So how do we get r squared using Stata? So what it is with Stata, everything is done for you. The only thing you do is just copying and pasting, copying and pasting. But there are times when you have to do a bit of manipulations here and there, which is maybe as you progress. For now, don't worry, you just copy and paste. So from our output, first of all, we have our ESS there. Okay, you also have the RSS there, you also have the TSS there. So the ESS is this one here, 5,288.61128, and then the RSS is this one here, the 30,282.2929. When you add these two, okay, when you add the estimated sum of squares plus the residual sum of squares, you should get the total sum of squares, which is the 35,570. So there are times when they are going to give you an output, and in that particular output, he is going to, let's say, is going to hide this number here, okay, the r squared. He is going just say to rub it, he hides it, and then the first question is asking you what is the r squared. So you go back to your formula. R squared is the ESS out of the TSS. You should be able to get this one, the 0.1487. So when you divide 5288.61128 divided by 35,570.9042, you should be able to get the 14.87%. Okay, so so that's the first thing that we need to know. Okay, so the interpretation is that about 14.87% of our variations are explained in our model. Okay, so we know that we only have 14.8% of those variations that can be explained using our model, and since our r squared is less than 50%, this is not a good measure of it, because we have a very low r squared, because if only 14.87% is explained by the model, it means that the remaining 80 something or 86% is not explained by our model, which means our model is biased. And the reason for this is simple. The number of explanatory variables, we only have one. In short, we're just making an assumption that earnings depends on the number of years you've spent in school, which is not true practically, because there are a lot of factors that affect your earnings. It could be the number of businesses you're doing is also going to affect your earnings. You might go to school, but if you don't have a business mind, you end up having less income compared to someone who didn't even go to school and yet they're doing businesses. So the reason why our R squared is very low, there are times when they can ask you such questions to say, why is this R squared very low? So the answer is, or in short, I'm sure by now you know that the R squared increases with a number of variables. So the more variables you add to your model, you should expect R squared to be increasing. Okay. Okay. So yeah, that's the first thing. So now we know how to get this number there. Okay. And then the number of observations basically is reported by status, just telling you to say you have a total of 531 variables. And then the F test, we use the F test to test the validity of our model. Is this model valid or not? So with that one, you just compare this to 4. So since the F value is 92, it means that our model is correctly specified. Okay. And then if you're using probability, you look at the 0.0 something. If it's less than 5%, then well and good. I'm sure these you know. You must have done these in class.
Yes.
And then with the R squared, with adjusted R squared, this one I think you've also looked at it in class. That the adjusted R squared only increase if the additional variable is significant. If the additional variable is not significant, then the adjusted R squared is not going to increase. And then I've just noticed that there's a question in your assignment which is asking about R squared and adjusted R squared. I want to tell you answers for assignment anyways. Okay, yeah, and then then with the degrees of freedom, these we know that how we get the degrees of freedom is just n minus k, and since we have 531 variables, okay, well, 531 variables, so the total degrees of freedom should be 530 because we only have one explanatory variable. So the n minus k, the n minus 1, so 531 minus 1 variable, we have 530. So that's how we get that 530 there. And then the MS is out of the scope of your course, and whether you believe it or not, you'll never encounter any question about the MS. Okay. And now, how do we report our regression output, or how do we give a proper interpretation of our regression output? So remember that we made an equation somewhere that yi is equal to beta naught plus beta 1 xi plus the error term. So in short, when you look at this output, the down one here, you have your earnings there, then you have your schooling there, then you have your constant there, then you have the coefficient, standard deviation or the standard error, you have the t value, you have the p value, then you have the 95% confidence interval. Okay, and when you look at the coefficient, so the coefficient for schooling is 1.35. Okay, the standard error is just 0.14. The t statistic is 9.61. The p value is 0.0. And what the 95% confidence interval shows us is that this coefficient is lying between 1.07 and 1.63, which is true because our coefficient is 1.35, and 1.35 lies between 1.07 and 1.6. And the other thing that we're able to tell is that when you look at the p-value, this p-value is less than 5%, which means that this coefficient is significant at 5% level of confidence because the p-value is less than 5%. So we can conclude that our variable is significant. You do the same with your coefficient. Your coefficient is negative 4, so negative 4.9. Standard error 1.9. The t-statistic negative 2.55. You look at the p-value 0.011, and since again this is less than 5%, it is significant, and this value is lying between negative 8.6 and negative 1.13, which is true because negative 4 lies between negative 8 and negative 1. It's between these two. Okay, so that's how we interpret the output. Is that okay?
Yes.
Okay. Now, how do you construct your regression equation from the output? So we've said that our thing should be should look like this. So I've got beta naught plus, then you have our beta 1, x1 plus the error term, in this case since the simplest form. Oh, sorry about that. So we have this as our regression, or we should have something like this as our regression. Okay, so now how do we write this using the information that we have on the table? Okay, so now we know that our yi is schooling. Okay, so our yi is schooling, and our beta naught is this constant, this one here. That's our beta naught, that's the constant. So that's our constant, plus the coefficient for schooling is that one there. Okay, so and then xi or x1, and then plus the error term. So in short, when you're writing your regression freehand, it's supposed to look like that. Okay, actually let's replace the x1 with the schooling like that. So in short, what we're trying to say is that yi, where yi is earnings, okay, so our yi is earnings, so earnings is equal to the beta naught is the negative 4.9 plus 1.35 schooling plus the error term, which means that we have managed to come up with our regression equation using Stata. That's okay, right?
Yes.
So that is how you do your regression in Stata. It's as simple as that. So the only part is only the only catch is on the interpretation. Just a second. Wait, what's that? When the work is not done. But you know where the catch is? If we finish those things today, I have to send them, they look at them, and then they send the money. No, it's not like it's in propoto. Like no, boom. Or maybe I can try to talk to them and say, 50% done, and you send the deposit. I know. So, what do we do? How far? Because I've not yet taken time to look at your week from the time you started. And after this one, I'll only have maybe 30 minutes or so to look at that. Then I have to go in another session now. How distance? Oh no. And for this, I'm supposed to have 2 sessions with her. One at actually I'm on a phone. One at 14, the other one at 18. 5 years. Anyway, we'll discuss. Okay, so yeah, that's what you're supposed to do. So I believe you can do this on your own, right?
Yes, I can try.
Okay, we all start from trying and then we get used. So yeah, you can manage.
Mm.
You can manage. 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 So what do we do now? What do we do? What do we do? What do we do? Oh, okay. Yeah, maybe we can also look at a multivariate regression, but now I'll stop using your data set because I may be giving you clues to your assignment. I'll use my own data set now. So let me just get my other data set. Okay, I'm using a different data set now. I'm going to
Okay.
give you clues. Okay, so let's try to do a multivariate regression and see how it comes out. So let's say we are looking at the impact of GDP, capital, labor force, government expenditure on let's say economic growth. Okay, so in that case, I'm going to regress. Let's say I'm going to regress GDP. Then I have capital, I have labor force, I have government expenditure, I have foreign direct investments, and maybe life expectancy. Those ones. Okay. So the key with this data is that even if you have 20 variables as explanatory variables, the output will still come out, the analysis will be the same, and all those things. Okay, so as you can see, the output has still come out and the analysis is the same. You have the coefficients there, you have the standard errors, you have the t, you have the p values, you have the 95% confidence interval. Like everything remains the same. The only thing that might change is how we interpret these, since we are now looking at a different data set. Yeah, but assuming that you were working with such a data set, yeah, the analysis would have been the same. So the coefficient so with this one, the analysis would have been the same. You're looking at the impact of these variables on GDP. Okay, so capital, how does capital affect GDP? So in this case, since the answer there is positive, it means that capital affect GDP in the positive sense. The more you have capital as a nation, the more you should expect GDP to increase. The same thing with the labor force. As the labor force is increasing, we expect the GDP to also be increasing. The same with government expenditure. If there's an increase in government expenditure, we expect GDP to also increase. Same with FDI. The more foreign direct investment you have, the higher GDP should be. Life expectancy, the more people live before dying, we should also expect GDP to increase. So that's how you analyze. So I'm now giving you the edge to your assignment because I've seen a question that is asking about such things. Okay, yeah, so basically the analysis will be the same whether you're dealing with a monovariate or a bivariate or a multivariate. The analysis will still be the same. Okay. Which other command should I discuss with you? Oh yeah, maybe before we run out of time, let me show you how we work with a do file. How we work with a do file. So what you do is this: for you to open the do file, you click on this comma icon there. When you click there, it's going to take you to such a page like this one. And then in this one here, this is where you post all your commands. All your commands, you post them here, meaning that this one is savable. You can save it, and later on you can refer back to it and use the same commands. So instead of typing, you can just use your do file. Okay, you can just use your do file and carry on with your analysis. Okay, so how do we do that? The first thing is that in our with a do file, if you don't put the slash at the beginning, okay, if you don't put those things like this, your commands will not be recognized. So first of all is before you start keeping your commands, first thing first is at least put even just one slash or two slashes. Then you can write anything, and your whatever you're writing will be in green. Okay, so we can let's call this our do file for class 1. Okay, so we call that do file for class 1. So we've given it a title. The next thing is we can just copy these commands that we are doing and putting them there. So the first thing we did was to tabulate. Then you can just copy that. You copy it, then you go to your do file and paste it. Okay, so you paste it like that. Okay, which means that let's say we have all the commands that we've done. Let's say we are tabulating age at some point. We did that, which means that after finishing our analysis with this data, sorry, my mind is about research. When we are done with analyzing our whatever we're analyzing with this data, we can refer back to our do file instead of us going back to square zero and start typing, tab this, do that. You can just go to your do file and use your do file instead. So instead of typing, just click and then the output will be coming, you analyze. You click, your output is coming, you analyze. So that's the whole purpose of saving our commands in a do file. In short, a do file is very handy. Okay, it's very handy because it saves your time. It also increases your efficiency. Okay, yeah. So those things. So basically, this can be the introduction to Stata. This can be the introduction to Stata, unless if you've got questions.
Yes. Is it possible? Is it okay? We just you, you help me answer the question 2 of our test 1. I don't know if you saw the question.
No.
It's under Stata.
No, I did not. I didn't
You
even.
didn't see?
I wasn't part of the invigilating team, so
Oh.
I didn't know what.
Okay, let me send you right now so that you just see the question too.
Okay, send it.
On my Siri.
Have sent.
Yeah, I've seen it. Question two. Oosh, all this paragraph. Okay, I'm just taking time to understand the question.
Okay.
Okay, so all right. So is it okay if I can take my time to look at this and then we start with this tomorrow?
Okay, no problem.
Yeah, because I'm also trying to finish up work for someone. She wants the work by 14.
Oh,
So if we give me time, I look at it and then we start with this tomorrow.
okay. All right. You send me the recording.
Ha! That's a lot of bundle.